Hi, how's all the members of Topsails Electric Flyers Association doing today? Today I thought I'd just make a quick video and explain to you what's all involved as far as components and so forth if you want to build a multi-copter. I've had a lot of people asking a lot of questions about them, so this will give you kind of a brief overview. If you are interested in them, just let me know and I can explain a lot more to you and show you what's all involved, and I'll even help you set them up. Just to give you an idea, the first thing you got to decide is what kind of frame you want. Then after you're done with the frame, the type of control board you want which controls your quadcopter, and also the type of electronic speed controller you would like to use, and the motor size. As far as the frames, there's quite a few different frames out there, but they go by size. On the table here I have two different size frames. One is a 450, one is a 650. This one particular one here is a 650 millimeter frame, and that's measured from motor to motor, 650 millimeters. The other frames I'm using, which are 450 millimeters, are from motor to motor also, 450 millimeters. And that's the type of frames you can buy. Now, the next thing to consider is the motors. As far as motors go, a typical motor, 900 runs anywhere from 900 to 920 kV is a good motor for a quadcopter, which is what I built. You can build one with 6 motors and one with 8 motors, but 4 works fine and it carries a heavy payload. And also, whatever type of motor you buy, they will be able to handle two size props on there. One is an 8 by 4.5 prop, or the next size is a 10 by 4.5 prop with the same type motor. And it depends on, gives you, the bigger prop gives you a little bit more stability on there, whereas the other prop uses a little bit more RPM, but I haven't really noticed that much difference between the two. So it's more or less a personal preference. Now, after you're done with your motor, your prop, and your frame, the next thing to consider is what type of speed controller you want. A lot of people have been using separate speed controllers, just like on your airplane. In this case here, I got separate ESCs, one for each motor, and they run about 20 amps each, which is a plenty. They also have on the market for these, you can buy what they call a quad ESC. This particular one here is 25 amps. It's got 4 ESCs all built into one unit, and each one is 25 amps each as far as max output, power output. And the nice thing about these quads, you only have 2 wires coming out to your battery, whereas if you got 4 separate ones, you're going to have 8 wires altogether, and you got to kind of make you a power distribution board in order to power all 4 of them ESCs, where this is a lot more convenient, and it's got your 3 wires coming out for each motor right from the same ESC, and they're long. They're about I want to say probably 20 inches, 18 to 20 inches long. The wires coming out of these, so you and if you got short wires on your motors, it definitely, especially if you got a big frame, they work out real nice. You don't have to make any extensions for your motor connections. Now, the next thing you're going to have to determine is what type of control board you want to buy. And there's approximately, on the average, 4 different type of control boards out there. The first one is called a KK board. That's your cheapest one. It's got 3 gyros for yaw, pitch, and roll. That's all it has. It's all digital, and you actually got to fly it like you get continual inputs on it, which is okay. It's flyable, and in fact, it's kind of a lot of fun, just like flying a helicopter. The next one up from that control board is a multi-wheel board. Your multi-wheel board has an accelerometer on it. It also has yaw, pitch, and roll gyros. It's got a barometer. It reads barometric pressure for altitude hold, and it also has auto level, which is real nice. If you get confused, let go, it just levels off itself. And the altitude hold is real nice too, because you can put it about 4 or 5 feet above the ground and implement your auto level and just fly it around at one particular altitude. It works really great. Now, the next board up is called a quadrennial zoom, and that's a nice board. It's very robust. It's round, and it's got nice cable connections coming off. You don't have a bunch of pins and all. They come off to hook into your receiver and your speed controller, so that makes it real nice. But it also has auto level, altitude hold, and it also has reads barometric pressure and has a magnetometer on it, just like your multi-wheel does. And the next board up from that control board is your, which is top of the line, is your nozzle. Nozzle is a real nice board. It also has reached barometric pressure for altitude hold, and has auto level and a magnetometer in it. And the other thing about your nozzle, which is top of the line, it comes with an external. You hook up a GPS to it. You can also buy different modules, and the more, it has so many waypoints stored into them, the more waypoints you want, the more expensive the module. That plugs also into your nozzle board. The nozzle board is nice and compact and uses real nice plug-ins. It also comes with its own power supply, this right here. And it also, the power supply has also got a built-in BEC on there for your receiver, which is real nice. So it's a nice board to use. Now, all these boards, there's two different Windows GUIs out there, so depending on what kind of board you use, depends what kind of program you download in order to program these boards. They've all got USB connections that plug into your computer, and you have to figure out what kind of driver to load on your computer, and also which GUI to download and use. And your GUI, for example, for your multi-Wii and your quadrenal zoom is the same as far as Windows goes, and you can download that, and there's a multi-Wii site. You notice I keep mentioning multi-Wii. Multi-Wii was generated, comes from your Wii game that you play at home, because the components that were used to build these boards came from the nunchucks that are used on your Wii games. The nunchucks have accelerometers and gyros in them. So a while back, some nerds got together and started building these processors, these boards with processors on them, and program what we call Arduino programming code that they use. And they took these components and put them on there and made them where you can actually fly a quad, and it controls a different RPM each propeller, depending if you're doing a left or right pitch and roll and yaw. And it's really amazing. There's no servos involved whatsoever. But they use your standard receiver if you're flying Spectrum receiver, 6110s or 6200s. Work real well. At least a 6-channel is what you need in order to take advantage of all the functions. But like this particular one here, with a multi-Wii board, you can also install on top of it. This is a GPS board. And this here has return to home and position hold with the GPS, where GPS is nice on there. So this is a lot of fun on there. So this is just to give you a brief overview on what's involved on building a multi-copter. And like I say, the quads work fine. I'm having a lot of fun with them. This particular one here with the nozzle on it, this is an excellent platform if you want to learn how to use first-person view. This one here has got the camera on it for first-person view. And what's nice about it, you can have your, if you're using goggles up here on your head, you can take it up, put altitude hold on, it'll sit there, put your goggles on, you can move around, move into yaw, and just kind of look around the area. And if you're getting confused, you just put your goggles back up, and it's right there. It's not like an airplane which you continue flying, you take your eyes off, it's gone. So that's what's nice about it. These are excellent platforms for learning how to use first-person view equipment. So like I say, this just to give you an overview. There's a lot more involved with it, a lot more in setting up your ESCs and your throttle calibration and your transmitter calibration using the program that comes that you download to your computer to program these boards and flash them if you need to. So if you got any questions, you want to get involved, just let me know. I'll be glad to show you. If you want to build one, I'll show you the best way to do it, and I'll even help you set it up and get it where you can fly right out of your garage. So other than that, hope you have fly safe, and hopefully I'll see you at the field.